Yeah, so hello everyone. My name is Frederik Proske. I'm an operations research analyst at GAMS, and I'm giving you the presentation from the GAMS perspective now, the previous presentation. Of course, it's some differences, but also some similarities. It's also about model deployment. All right. I guess, or I assume that most of you are familiar with the concept of an algebraic modeling language or an algebraic modeling system and the benefit it provides, like being able to develop your models independent of the solver you want to use, or having a syntax that is close to the algebraic model formulation that you are used to. And oftentimes, the model developers or the OR experts are in the situation that they need to build the model for users who are not experts in the field of OR. And that obviously has some consequences in terms of how you want to design your model. For example, probably someone who is not familiar with terms, with OR terms, won't find it useful to have an information like the model is infeasible. Instead, he or she would have some more detailed information on what went wrong, what data inconsistencies there are, or why the model is infeasible, and you can do that, of course, perfectly fine within the modeling, the algebraic modeling language. But there is also another side of the thing that the users or planners, how they are often referred to, also want some kind of framework for graphical representation of the data that they feed their models with, or the results that they get back from the optimization process. So in order to do that, we have been working on some model deployment frameworks. And because currently there is basically two options you have for fulfilling this need for the planners. You can either buy one of the existing deployment frameworks that are out there, such as IBM Decision Optimization Center. FICO also has some deployment framework. But they are oftentimes very expensive, and that's some feedback we get from our customers. So oftentimes like 10 to 15 times the price of the modeling system, which some might argue is not very cheap either. So this first option is pretty good and also expensive. The second option you have is, of course, to use one of the existing APIs that almost all the modeling systems are shipping with, and just take matters into your own hands and start deploying, start developing your own deployment framework. However, this, of course, requires a lot of programming effort. It can lead to very sophisticated and also highly customized results, as you can see here. But yeah, again, a lot of programming involved, and thus it's also kind of expensive in some sense. So what we were doing in the past months is we have been searching for a way to make things easier. So in order to provide our customers with a very limited amount of work that is required in order to take the model and turn it into a user interface, and also with very limited financial resources that they need to spend. So we wanted to go from our model to some interface that is web-based in our case. And what we found is a framework and a package in R that is called Shiny. And it's an open source package that is especially made for building interactive web applications with relatively little effort in terms of programming that you need to do in order to develop the application. And what do our customers or those who are having the GAMS model either already developed or in process of developing need to do in order to turn the model into a user interface, into some graphical interface? And we wanted to keep this as simple as possible for various reasons that I'll come back to in a second. And what we came up with, or what the result that we got, is we only need to do basically three things in order to turn our model into a user interface. And that is telling the model what are the inputs that I want to feed from the UI into the model. There can be other inputs, of course, coming from external databases or whatever, but what are the inputs that I want to receive from the UI, and what are the results that I want to display back into the UI. So this is basically all you need to do, And then you, of course, need to say that you want to start your web user interface now. And you can do this from within the IDE. So while you're developing your models, you can already have some visual representation, which helps of not only the end users, but also you as the developer in order to debug your model and on those kind of stuff. So with just specifying inputs and outputs, you already have an interface that you can that has a tabular form for both the inputs and the outputs, because this is the most generic form in which you can visualize data. And also, we have support for pivot tables, which is by default turned on. So just by specifying inputs and outputs, you can already have some visualization in the form of pivot tables and pivot charts in this case. Again, only by specifying inputs and outputs, doing nothing more. But of course, you can do more, and I will go back to that soon. So how do you do that? You basically annotate your model with this compile time annotations that is just saying on external input, off external input, and all the declarations of the sets, parameters, and so on are being read by the UI. And the same goes for the outputs with on external output, off external output. And then you just have to include some GAMS file, which is doing all the magic, basically. And I mentioned that, of course, you don't have to stop with these initial tables and pivot charts. You can annotate your models by specifying, for example, that you want to have this scalar as represented as a slider instead of a table, and you can do that by basically annotating your model parameters and scalars within the description of your parameters. So you can this is just some basic JSON syntax that you can write within your model if you want to have a slider, drop down, date selector, or all kinds of those things. And the second step, so I don't want you to see these as like a recipe of steps that you need to follow, but if you are happy with the first step, then you can already stop there, and you have a perfectly valid graphic representation of your model. However, if you want to have more advanced graphics, we added those options as well. And again, we don't want our users to do a lot of programming, but instead a lot of configuration. So we want them to have some interface which is quite intuitive. And we again chose JSON files in order to specify what you want to visualize and how you want to visualize it. And then you can go from those basic pivot charts to some more advanced graphics. We all support many R tools currently that all come with a vast amount of customization options that you can specify within this JSON syntax. And if that's still not enough for you, and you are a big enterprise company or whatever, and you want more sophisticated graphics or some framework for managing the different models you have and the different users you have, you can also do that within a framework we support that is also based on Docker, and it can both be deployed on a local machine or a server-based solution, and it comes with enterprise features like user authentication for social authentication, LDAP, all those stuff. And also, because it's Docker-based, it comes with all the benefits you get from a containerized application, like load balancing, rolling updates, scalability, and all these kinds of stuff. And I talked about more sophisticated graphics. Of course, there is only limited options you have with this kind of declarative form of declaring what graphical representation you want. So we also added the option for you to create your own R graphs within the framework, and we can include these with this use of modules, so you can visualize more advanced graphs that you can come up with like this. Okay, I'll now come to the demo part of my presentation. So I want to do this by giving you a quick example that is kind of easy to understand. This model is basically trying to approximate the Dow Jones index with a certain given number of stocks. So we want to have a subset of the Dow Jones, 30 Dow Jones stocks, and we want to approximate the Dow Jones by this limited number of stocks as good as possible, and we do this by minimizing the absolute deviation from the index, and that's basically all the model does. So we have this parameter, or the scalar parameter max stock, which you can of course set, and then you get the approximation. All right. Let's go to the demo. So, as you can imagine, I'm pretty nervous giving a live demo of a development version of the software, but let's hope all goes well. So this is the framework we've been working on, and now let's say I want to import some local data. I want to import an Excel spreadsheet, which I should have put on the desktop right here, and it's loading in the data. And you have this static data from 2016, pretty old, I know, and also some sliders for selecting the number of days you want to use for training. So the data just is some stock data from the past, from 2016, and we want to use some of the data for testing, and some of the some of the data for training, and some part of the data for testing, in order to see how well it performs in the training stage as well as the testing stage. So let's set the number of stocks we want to select to 6 in order to see some more. And let's also go to some graphical representation. We can see the Apple stock seems to be not really well. There seems to be some problem in the data. So you also have the option to remove the Apple from the data. And notice that we have 30 stocks which are in the Dow Jones at the moment. And if I remove this stock, let's remove all the data. And now this will update to 29, because obviously we can also only have 29 stocks at maximum now that we removed one of the stocks from our data set. So these data sets can also be interactively combined. And then we just solve the model. It's running GAMS in the background, and in a second it should display some results. All right, and then we see how our portfolio is structured, so what stocks we select and the percentage that we select, and we also have the ability to see how well it performs. There is a graphical representation that of course also gets imported from GAMS, this line that says this is the end of our training phase, which we see our data performs approximates the Dow Jones pretty well, and afterwards of course it goes further apart, and we can also visualize the same in a histogram in order to see how well it performs in the training and in the test stage. All right, and then we also implemented some comparison functions. So in case you want to see how the data, oh, that's not what I wanted. We're getting closer. Okay, there we go, and you can see how it how the different data sets are comparing against each other. So if we only select 2 stocks, we see that it performs really badly after the training stage, and it does better with 5 stocks and with 10. And we can also visualize the absolute error. I mean, I think you get the gist. And to go even further, we can also take this to another level. This is using some embedded Python code that we can include in our GAMS models in order to fetch data live from the internet in order to not use data from 2016, but instead let's load in the data from the 1st of January 2017 until yesterday, and then we can solve the model, and it's fetching the data live from the internet with embedded Python code in our GAMS model, and then once it's done fetching, it's running the same model but with more recent data, and it should also visualize the same thing, but this time with more recent data that we just fetched from an API from the internet. All right. Let's summarize. So I've talked about a new way of deploying your GAMS models within a web user interface, which is tightly combined with the GAMS model, which you can use those annotations in order to turn your GAMS model into a graphical interface. And we support file exchange via local files and also an internal database that is used by the interface. You can modify, of course, your input data, visualize them with date selectors, sliders, drop-down menus, all kinds of stuff. You also have extensive graphical representations or graphical options in order to visualize the input and output data. We support multiple users and multiple applications within this Docker framework that I showed you quickly. We also have user authentication, of course. And we do believe that this is a quite intuitive tool for planners and also for developers who are having the possibility to, very early in the stage of development, already being able to visualize the data. And then some outlook. So we want to turn this thing, of course, to support batch configuration, so configuration of the same model with multiple instances for a batch run. So we want to kind of move GAMS out of the Docker. That currently the application and GAMS is in the same Docker. Of course, that's for development, works well for development, but we want to move GAMS out of the Docker and have it kind of as a separate container in order to do load balancing and all these things with different applications that are running on your server. And what we also want to experiment more with is container orchestration frameworks like Docker Swarm or Kubernetes in order to get some more and better feeling about how well it performs in terms of load balancing and high availability and scalability. Currently, that's not our focus. That wasn't our focus. Our focus was to get an intuitive and fast setup, a kind of proof of concept. And now that we see it works quite well, we want to take this a step further and experiment with those features that enterprise companies are frequently requesting. Yeah. That concludes my talk, and I'm happy to answer any questions.